Now, if you've got an array of stuff, the whole point of it is that you want to be able to go through and do things to everything in the array. So there's actually going to be tons of situations where we're going to want to write a loop that iterates through an array one element at a time. We also call this process a traversal. And you can imagine situations when this would be useful, right? If you have the SAT scores of every student in the county, if you have the name of every student in a school, if you have the mileage of every car used on a lot, anything where you have a collection of similar objects or data that you want to do a similar thing to, yep, we're probably going to want to loop through it. So let's take a look at some examples of looping through an array. In this case, we'll keep on using that same array that we initialized in the prior lecture videos, this array ABC that holds 500 int values, just as our toy example. So suppose we wanted to sum all the elements of an array. Right? Each time through, the loop adds a different element to this running sum. Okay, so in the first iteration, we add ABC sub 0, and so on, and so on, and so on. So first, let's think about some pseudocode. We want to have a variable that keeps a running sum for us, and for each element in the array, all we want to do is add that to the running sum. So what I'd like for you to do now is pause the video and take your best shot at a loop that does this. So please pause the video. I'm going to start up again in 1 second. Here's what a Java solution to that pseudocode looks like. You can tell it actually looks really similar. We declare our sum accumulator variable, initialize it, and then we loop from I starting at 0 until I is less, as long as I is less than 500. So in other words, until 499 inclusive. And we say for each item, sum plus equals ABC sub I. First iteration, we're adding ABC sub 0. Last iteration, we're adding ABC sub 499. Now, if I wanted to modify this so that it works with an array not just of length 500, which ABC happens to be, but an array of arbitrary length, right? Or if we don't know exactly how long ABC is going to be before we run the program, well, then in that case, we would just make one slight modification, and that looks like in the condition I is less than, used to be 500, now we actually just make I less than the length of the array. So whatever length ABC has when it enters this loop, that's how many times this loop will run, and we'll add everything in there. That's if you want to make it robust and resistant to different array lengths, this is what you do. We can also count the occurrences of a particular value in this array. So we want to count how many times a particular number appears in the array. So as a first exercise, stop and think through some pseudocode and then translate that pseudocode into Java. Okay, the pseudocode that counts the number of times that a particular value appears in an array of 500 integers. So go pause the video, come back in a second. You can see my pseudocode and my Java code here. Well, we want to declare and initialize x. X is what we're looking for. We want to declare a variable that keeps count of how many matches we found. And for each element in the array, we basically just want to check, hey, is this a match? And if it is, we add 1 to our counter for the matches. The Java code looks pretty similar. If you'd like, pause it for a second and take a look. Key here is every time we're referring to ABC sub I, the current element of the array. Every time we go through the loop, it's a different value. Okay, so if you want to expand this to not just how many times does this appear in the array, but rather to is this present or absent in the array period, we could just run the prior method on it, and if the thing that we're looking for appeared 0 times, well, we know it was absent from the array, and if it appeared more than 0 times, it was present in the array. But we could also think of it in a slightly different way to make our code a little bit more efficient, and essentially that just means breaking out as soon as we found a single match, because if we found a single match, then we know we're ready to return true or false in response to the method call. So again, pause the video, write some pseudocode and some Java code that takes this idea and applies it. The idea that we can break out as soon as we have found a single match, and that determines that the value we are looking for is present in the array. Pause the video, take a stab at it. Okay, here's my pseudocode. We start by declaring whatever value we're looking for, whatever the target is. We also declare a variable to keep track of whether or not we found it. Okay, so I was thinking of that as a Boolean variable. For every element in the array, we check, hey, is this element the target that we're looking for? If it is, set the Boolean and break out of the loop. Stop looking because we know we found it. We know that it is present. Otherwise, if that element wasn't, well, it could still be the next one, so just do nothing. And think about whether we actually need that last clause. Here's what my Java code looked like. Again, it's all really the same. You'll notice that I took out that unnecessary else clause. That's gone now. And afterward, I've tacked on a little if statement that uses the Boolean, which we initialize to false, but gets set to true if we find the element. It uses that Boolean to print a final result. Okay, last of these little demos. We probably want to be able to find out where the first location of a particular value is in the array. Take a second, pause this video, write some pseudocode, write some Java code that does this. Pause the video. We'll be back in a second. And here's what my solution. Looks like. I declare the variable that I'm looking for. I declare a variable to keep track of the location, initialize that variable, the target, and then we initialize the location to -1, so as if it's not there. Search through. If this current element is equal to the target, well, capture the current location, the current index, in LOC, in loc, and break out, because we're done. We found the first location. If location is still -1, we know we didn't find it. Otherwise, print that we did find it and where we actually found it. Last item, we saw this before, I just want to say it formally. If we want to work with arrays of an arbitrary size, so not necessarily 500, or maybe we don't know when we're writing the program how big the array will be, well, in that case, again, just use abc.length, that public instance variable, use that in the condition of your loop. And that means you'll traverse the entire loop no matter how long it is. You're not bound to that particular literal value. Big things before you close up shop. Make sure you can write a loop that prints all the items of an array. Make sure you can do it backward too, so printing all the elements in reverse order. Make sure you can write some code that finds the first occurrence of a negative number in the array, or -1 if there are no negative numbers. And read these code segments. Make sure you can translate or identify what they do. Maybe make sure you can describe it in English. That's all for today.